Hi guys! I know a few people are struggling with this checkpoint one, and you are my guys that kind of scored a little higher on iReady, so I did give you ones that are a little bit more of a challenge. Alright, so let's look at this one. In diagram, JK is perpendicular, remember that upside down T means perpendicular, to FG. HI is perpendicular to FG. So I would really encourage you again, if you can, mark these on the diagram. JK, perpendicular to GF, so that forms a right angle. HI, GF, again, forms a right angle here. We want to complete the proof that JK is parallel. Remember, this means parallel. Let's kind of bring back all those fun vocab from Unit 1 here. Remember, those symbols mean perpendicular. Alright, so since JK is perpendicular to FG, that means the measure of, let's see, JK, FG, okay, MLK equals, no, I think perpendicular. We want that MLK is 90 degrees. Remember, that's what the definition of perpendicular is. Means that it forms that 90-degree angle. Also, since HI is perpendicular to FG, angle GMI is 90 degrees. So we can say that MLK, which is 90, is congruent to GMI because they are 90. They're both 90 degrees. So I can say they are congruent by the converse of, notice these two angles here are corresponding angles. So by the converse of the corresponding angles theorem, these two lines are parallel, HI and JK. Remember that corresponding angles said if the corresponding angles are congruent, these are corresponding angles, they are congruent, they're both 90 degrees, therefore the lines must be parallel. All right, yay! Ooh, this looks like a fun one. Let's try this one. In the diagram, QR is parallel to ST. QR is parallel to ST. All right, and angle VUY is congruent to VWX. VWX. So the two they marked in red there. We're trying to prove that YXW, so we're trying to prove that this angle is congruent to NVR. So we're trying to prove that these two angles are congruent. That's what we're trying to prove, just so we kind of know where we're heading. All right, so let's look at it here. So by some theorem, we're looking at angle VUY is congruent to YXW. So it's saying this angle is congruent to this angle. Notice these two angles are alternate interior. Since we know QR is parallel to ST, these two are alternate interior. So by that alternate interior angles theorem, angle VUY is congruent to angle YXW. All right, so YWX YWX must be congruent to YXW by the blank property of congruence. Well, notice we originally said VUY is congruent to YWX. Then we said VUY is congruent to YXW. Notice we have them both here, same angle, being equal to these two angles. So what theorem then tells us these two must be equal to each other? That's the old transitive property of congruence. All right, so we know this one again is the same measure as these two. All right, by the blank angles theorem, YWX, so this angle, is congruent to NVR. These two are congruent because, if you notice, they are corresponding angles. They're in the same relative position, both on the top and to the right of the transversal. So those are corresponding angles. All right. So notice we proved that YWX was equal to YXW. Now we said YWX is equal to or congruent to NVR. We can now state what we were trying to conclude. YXW is congruent to NVR. And again, the reason we stated that, you can see it here. We have the same angle being equal to two different angles. So we can now say they are equal to each other or congruent to each other by the transitive property of congruence. Yay! Oh, I got a terrific. I forgot to do my pirate accent. All right, let me try another one here. Matteo has already proven the alternate interior angles theorem. Now he wants to prove corresponding angles theorem. All right, so in this diagram, PQ is parallel to RS. That's our given information. Why is RWV? RWV, that would be this one. Why is that one congruent to QVW? All right, we know these are parallel. I mark it with the little parallel symbol. So that makes these two angles alternate interior. So the alternate interior angles theorem says that they are congruent. All right, and we're trying to prove that RWV, so this one is congruent to PVT. So we're trying to prove that it's congruent to this angle. So how is this angle related to this one we already know? They are vertical angles. And remember, with IXL, you need to be very careful to use the tools they give you here. So I'm going to say that angle PVT is congruent. It might need a space in there. I forget if it's picky about the space. That is congruent to angle QVW. Again, we said the reason that this one is congruent to this one is because they are vertical angles. Vertical angles are always congruent. Those are the ones on either side of intersecting lines. All right, so we said RWV is congruent to QVW. Then we said PVT is congruent to QVW. So the reason that RWV is congruent to PVT, it's the one we've been using a lot, the old transitive property of congruence. Super. All right. Let me see if I can pop back. Remember, you need to get to 50. Let's see if I can pop back and get a different question. Let's see one more time. Let's look at this one. Complete the proof that angle GMJ is congruent to JMP. So these two are congruent. I'm trying to prove that. All right, as usual, we're going to state our given information. All right, and we're saying angle EMI is congruent to JMP. So what reasoning do we have for stating that that angle is now congruent to this one? You got it. It's the old vertical angles. All right. So since that is congruent to EMI, and I know EMI is congruent to KNH, I can say JMP is congruent to KNH. And again, make sure you use the tools they give you. Congruent. And make sure you use the angle that they give you. Don't use the less than greater than sign over on your keyboard. KNH. Again, that's the old transitive property. All right. So now we're looking at some alternate exterior. So let's look at the lines that we already said are parallel. Let me change this to red. So we said IJ is parallel to KL. We already proved that. So that's the lines, the parallel lines we're going to look at. And if I look at this transversal, GH, we're going to use that as the transversal. We've got some alternate interior angles. I'm sorry, alternate exterior angles right here. If you remember, alternate exterior angles are also congruent to each other. So, again, using the angle tool, K and H must be congruent to angle GMJ because they are alternate exterior angles. And notice we said KNH is congruent to GMJ. Oops, I forgot to put my angle measure in there. IXL's going to yell at me. There we go. Put my angle measure in there. And I also stated one step above that KNH was congruent to JMP. Because of those two statements, I can now say JMG is congruent to GMP. JMP. Again, thanks to the old transitive property of congruence. Yay! All right. So hopefully that helps you guys with some of these problems. I will send this video out. I'll actually put it right in the IXL so that you guys have a chance to look at it. If not, stop by one of the help sessions. We can go over any questions you have.